Hello learners, I hope you are doing great. So far, we have studied about various kind of changes that take place during chemical reactions. What kind of changes, children? We talked about change in color, change in state, precipitate formation, evolution of gas, and then we also talked about change in temperature. Yes, and then also we studied about balancing the chemical equations. And I'm sure you already know that atoms can neither be created nor be destroyed, and therefore mass of reactants must be equal to mass of products during a chemical reaction, right? So now in this video we will be going to study about chemical reactions in details. We will be talking about various types of reactions now. Okay, so let's talk about types of reactions. And before proceeding with types of reactions, we must understand what is a chemical reaction. So what kind of change that takes place during a chemical reaction? What happens when chemical reaction actually occurs? So let's understand that by an example. So as you can see on my screen, that there is burning magnesium ribbon. What happens when magnesium ribbon burns? When magnesium ribbon burns, a beautiful white dazzling flame appears. So if beautiful white dazzling flame appears, what is the reaction that we should write? So the reaction is, I'm sure you are already aware of the reaction. What is happening? Magnesium ribbon is solid in state. It reacts with oxygen gas. What is the product formed, children? The product formed is MgO, magnesium oxide solid. So, what happens in this particular reaction? First of all, we will always check whether the reaction is balanced or not. So, this particular reaction is not balanced because I can clearly see magnesium oxide has one O. While here on the LHS, there are two oxygen atoms. So, I must multiply 2 here and multiply 2 here. Now the reaction is balanced. So in this particular reaction, if we understand what is the change that is taking place, can I say that the bonds of oxygen molecule is actually breaking because there are two atoms present in one oxygen, right? So if two atoms are present in one oxygen, so their bonds are breaking, and then only one of the oxygen is combining with one of the magnesium atom in order to form MgO. So, do you see that is it possible that both the oxygen atoms combine with one magnesium? No, this particular formula does not exist. So, what is actually happening? How this MgO is formed? This particular MgO is formed because one of the atoms of oxygen is combining with one magnesium atom. And how one of the atom of oxygen we have got? Because the bonds of oxygen atoms, they are breaking in order to combine with magnesium. So can we say during a chemical reaction, what is happening? There is breaking and making of bonds between atoms to produce new substances. So children, new substances can only be formed when the previous bonds are broken and new bonds are made. Can you guess which two atoms are making bond here? Yes, magnesium and oxygen, they are making bond in order to make MgO. I hope you have understood this. Now, let's proceed with the types of chemical reactions. So children, when we talk about types of chemical reactions, there are 5 basic categories of the reaction. The first one is chemical combination reaction, also known as chemical composition reaction. Then chemical decomposition reaction, also known as chemical decombination reaction, chemical displacement reaction, double displacement reaction, and the last one is oxidation and reduction reaction. So we will be discussing these types of reactions in details with variety of examples and many activities. So let's proceed with the first one. So now let's proceed with the first type of reaction, and the first type of reaction is combination reaction. Children, combination is also known as chemical composition reaction. Why are we calling it combination? What is the term combination or combine doing here? Because you will find in these reactions 2 or more compounds, they are combining together. What is the meaning of combining? They are attached with each other in order to form a new substance. Let's look at the examples here. So, if we talk about burning of magnesium ribbon, what happens in burning of magnesium ribbon, children? Magnesium ribbon is Mg, solid. And when we burn magnesium ribbon, it takes place in the presence of oxygen, right? So, O2 is required for the process. So, when magnesium reacts with oxygen, actually what is happening? Magnesium is combining with oxygen to form a combined product. Yes. And what is that combined product, children? It is MgO. Why? Because magnesium has 2 plus charge and oxygen has 2 minus charge. So, when you crisscross their valencies, you get MgO. Is it the balanced equation? No. We must balance it, as we have 2 atoms of oxygen on LHS. We have to make 2 atoms on the right hand side as well. So, multiply 2 here. Now, magnesium has got 2 atoms now on the right hand side. So, I should put 2 here to equate it. Right. Now, the question arises that why are we calling it a combination reaction? So, there must be 2 or more reactants. They must combine to form one single product. Are we getting one single product? Yes, it is MgO. Now, let's talk about the next reaction. So, if we have burning of coal, what is coal, children? Coal is carbon. Yes, coal has the composition of carbon only. So, it is C. Carbon is burnt in air. So, you know that any substance which burns in air, it is actually reacting with oxygen. So, if it is reacting with oxygen gas, what will happen? Carbon will combine with oxygen, and what is the product formed? Carbon dioxide, CO2 is formed. Now, similarly, when we talk about formation of water, what happens in formation of water? So, water is formed by reaction of hydrogen gas with oxygen gas. When these 2 gases react with each other, in other words, I can say when hydrogen gas is burnt, then what will happen? It produces H2O liquid. And it is not a balanced equation, children. It is always compulsory to write a balanced equation. So, oxygen are 2 atoms here. So, I should put 2 on the RHS. Now, hydrogen are 4 in numbers. 2 times 2, 4. So, let's make 4 hydrogens here by multiplying 2. The reaction is balanced. So, the question arises, why are we saying that these are the examples of combination reaction? Because in all the 3 cases, can we say that the reactants are combining to form a single product? Are we getting single product in burning of coal? Yes, it is CO2. Are we getting single product in the formation of water? Yes, it is H2O. So, in all the 3 reactions, single product is formed. So, the reactants are combining together. And what is the definition of combination reaction? So, when 2 or more reactants or elements or compounds combine to form a single product. So, this is mandatory. There must be a formation of a single substance. So, in general, how can I write the general reaction or general equation of this particular type of reaction? It is done by when you can write A plus B will form AB, yes, or you can say A plus B forms another compound C. So, when A and B are combining to form AB, a single product. So, we say it's a combination reaction. So, let's do more examples and the activities related to it. Hello children, let's understand an interesting activity related to combination reaction. So, here in this activity, what are we going to do? We are reacting quicklime and water. Yes, so the question arises, what is quicklime? Quicklime is calcium oxide. What is quicklime, children? Calcium oxide. So, what are we going to do? We will take a beaker, we will put water in that, and in water we will add quicklime, which is CaO. So, when they will react with each other, what kind of observations actually appear? So let's understand that particular observations by looking at the animated video.
Take a beaker and place in it a few pieces of quicklime, calcium oxide. Slowly add cold water in the beaker till it is half filled. You observe that solid calcium oxide pieces start crumbling with a hissing sound to form powdery mass. The white powdery mass rapidly mixes with water. It appears as if the contents of mixture are boiling. Water vapor is seen above the surface of water. Touch the beaker from outside to check whether its contents are hot or cold. You observe that the beaker and its contents become very hot. Why? Reason: calcium oxide reacts vigorously with water to form calcium hydroxide, slaked lime, with the release of large amount of heat energy. CaO solid plus H2O liquid forms CaOH2 aqueous plus heat energy. Conclusion: you notice that two compounds, calcium oxide and water, combine chemically to form a single product, that is calcium hydroxide.
So now, as per the animated video, I'm sure it is an interesting activity that you have observed. And in this activity, what kind of observations actually happen? Now, if you see in this particular activity, so calcium oxide when treated with water, see what amount of steam is released, right? Is it steam? So why these fumes have appeared, children? It is because that there is a lot of energy released during the process. Yes, what kind of energy? Why there is energy? So let's write the equation first and then let's discuss what has happened during the process. So calcium oxide when reacted with water, they combine to form calcium hydroxide. Now what is calcium hydroxide? What is the other name of calcium hydroxide? It is lime water. It is also known as slaked lime. Slaked lime. So children, keep it in mind the common terms that we usually use for various compounds. What is the common name of calcium hydroxide? It is lime water or slaked lime. Because we are calling it lime water because we are treating lime. What is this? This is quicklime. Calcium oxide is quicklime and we are treating it with water. So lime combines with water to form lime water, right? So lime combines with water to form lime water. So in this particular reaction, there is lot of energy released. So I must write that it is with the energy released. So energy released during the process. The energy released during the process makes the container very hot. So solid calcium oxide pieces start crumbling with the hissing sound. So initially, as soon as you pour water, a lot of hissing sound is produced to form powdery mass. Which powdery mass? Calcium hydroxide, and large amount of heat is released during the process. So these observations are very important. Please make sure to learn to understand these observations and you must know the reaction involved in all the activities. I hope you have understood this activity. Thank you.